Those joining online, just give me a while to set up, yeah? I mean, you're early, so you can just settle down first. Okay, while I set certain things. La, 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 la. Okay, where's the... Hmm. Hey, oh, they have a very cozy crowd, so you're in luck. Just give me a while to check certain things. Hmm. Okay, I think I'm good. Okay, so we just wait for a little while for the crowd to settle in, Brandon. So maybe depending on how the crowd is like, I'll start in maybe 1:30 or 1:35. Yeah, but not to worry, you can just chill. Give me a moment. This will be the content of one for today. Alright, I understand that I do have like syllabus and things like that, so let's check that. You sign up your web for the so it's in the chat. Give it a click, okay? Don't need to do any questions and after sure as the stuff goes by. Okay? Alright. So have a flip to get familiarized with the content or what we are gonna go through in particular. Okay. Mm. Yeah. Yeah, I think I'm good. Nice. Okay. Okay. All right, my online side, if you can hear me, all right, I think there's only one of you all. Just do me a favor and drop me a thumbs up. You can hear me, yeah? Awesome. Thank you, Jian Huan. Okay, just give me a moment, yeah? Because for me, this starts at example, so we working with with manufacturers buying the laws, we use so ours is embedded. Kalau ada apa for if we send me everything. What's the good that there's a workflow? Sometimes there's a need for our really see a movement.
Super like significant. I expect like
Based on the skills that you see, what the problem question they about swimming. And for me, it's not go through everything. I just not possible. So I know the other people is not sending this people to buy the first one. The rest of the topics they last day which they do some. Although from that, they do that. Really.
Yeah. Yeah, drowning in their student.
Yeah. Brandon, how do you get to know about this event? Your parents send you or
Personal assistant.
sorry?
Personal assistant.
Oh, your sister came here for IP stuff as well?
No.
Or normal like other subjects? Oh, okay. So you're here to just to get a feel of how it's like in terms of. Okay, no problem. Understand, it's okay. So just check the content is what you have learned in school, because I've specifically picked this topic based on like the demographics of the schools around here. Yeah.
School. Our school is mostly that in what country?
What you're the equation.
There's also a bit of geography.
Okay, no problem.
Mostly geometry.
Yeah, correct. Because I handpicked this topic because mainly people struggle in geometry lah. But you see how it goes first, alright, for you. Yeah.
Is there trigonometry?
Trigonometry, unfortunately, for this package, no lah. Yeah, because I've handpicked a few topics based on the syllabus I've seen due to the demographics of the schools around here. Yeah. That's why these few topics. Just wait a while. I think the crowd is slowly coming in. I only have today we have a very close crowd. There is more that signed up, but yeah, since you get the idea lah. They say it's free, then you should get it go because you don't have anything for that. But yeah, there's more. A little bit more. Hello, you are here for the simple IP. Sorry. Oh, manufacturer. Wait, can I get your name? Oh, Trevor. Okay, no worries. All right, let me take a look. Trevor. Okay, found your name. Just take a seat. Okay, today will be a very cozy crowd, so you can just wherever you can. Do you have the hard copy material with you? You managed to collect? No, it's fine. As long as I can see yours. I have an attendance list too much, so as long as I can see your name in the attendance list, it's fine. Just take your pick, have a seat. Yeah. You have the material? You have the. Okay, awesome. Right, let's take a seat. Then we'll get started in a while back. Okay, so I suppose that we will. Okay, I have 3 here. Yeah, okay, we do have some. Yeah, let's take a seat. Yeah. Today, I don't have much coming to the center, so it's really more or less just Okay. Okay. I'll try to get your names so that I can inquire. Okay, I will start at around, I would say 1:30, 1:35. All right, so you'll just chill accordingly. Is it hard to see the screen or a bit bright? Yeah, okay. No, that's why I say free sitting in this case lah. I mean, first come, first serve lah. So you all pick accordingly. Yeah, I think I'll start around 1:35 lah to get the crowd to slowly come in. Okay. So when I'm about to start, I'll give you a heads up. So you just chill around here. Okay. Mm. Okay. Well, just make sure because this topics can be a bit fast, I email, so just check when you're the topics there are within what you've learned, right? Just check. Yeah. So don't just wait for you. Yeah. That's the main deal. Otherwise, you just try to get as we move. Okay? Make sure you can because these topics are picked again based on the demographics of the schools here. Like, yeah. Yeah, I know it's 1:30, but I'll just wait a bit more, maybe for 5 minutes or so. If there's no one else, we will start soon. Okay. So my online site, which I have about 7 of you all right? Okay. So yeah, just take it chill. We will start soon in a while. Okay. And for my people here, it's gonna be very cozy. So yeah, be prepared for being for quite some back and forth lah. Is it very warm here? Is everything okay for you all? You can, huh? It's all right, huh? Awesome. Alright, you know what? Let me just start off it accordingly. I think we should not wait too much longer as well, because I don't think the crowd is coming in, except for the online side lah. So I do have a few people here. All right, so for the online side, I'm actually gonna start off soon. So just get yourself prepared, warmed up, and yeah, I will start off very soon for you. Okay. Yeah, it's gonna be long and draggy. I understand 3 hours is very long, so I'll explain a little bit on what's gonna happen for today for you all. Okay, so what's gonna happen for today is this 3 hours long. It's not gonna be me trying to blabber too much as possible, because it's a very long, intense session. So as much as I can, I'll give you all breaks in between so that you all can have some breather or any questions that you all have to lah. Okay, so yeah, just a very good afternoon to everyone here. Welcome for this September revision event. Okay, so thank you for coming and spending your afternoon with me for these 3 hours from 1:30 to 4:30. All right, so just in this case, let me do a brief introduction of myself, and you may be wondering who is this teacher here teaching you lah. Because I don't want you to be like, okay, I'm just talking and talking, and you're wondering who is this particular person that's teaching you, and then you'll be like, okay, so this teacher's blabbering, what are you talking about? Okay, so just a brief intro of myself. My name is Jason. You can call me Teacher Jason, Mr. Jason. Or in this case, if you feel like you don't have the mood to even talk, okay, just raise your hand and culture if you have any questions along the way. Okay, subjects I teach, basically IP math, that's why I'm here, and basically all sec math lah. Lower sec math, E math, A math, or IB math in particular. Okay, any branches from there. So some parts of myself, if you're wondering what I'm teaching here, or whether I will be able to teach you. So for my side, I'm graduated with a degree in math. So in this case, you can be assured that the math concepts I'm teaching you is definitely it's definitely accurate lah. So I've been teaching for 6 years already. More than 200 students. Okay, you may wonder why the number comes about. Because what happens is I used to teach for this institute called Genibook. Have you heard of them? Yeah, I used to teach there. And then, when I actually teach this kind of very wide style, it's like one too many. So that's why the numbers. Okay, this 70% over here, okay, is just a rough gauge, okay? But this 70% happens because of how I teach, okay? So for me, when I teach, I actually want you all to understand, not just say, okay, this question, you tackle it this way. No. I want you all to understand the rationale behind. Understand when you all come here, you all know the concepts already, or somehow know. But as we go through these questions, I want you all to have these particular thinking processes as we go along. Okay, so also a little fun fact, I kind of want to check in towards my teaching journey. So if you have like social media, which I believe you all have, or if you all don't, it's fine. Okay, I do have a social media account. Okay, it's a little bit random. So you can follow me over there, quite easy to remember. It's just my name and then a teacher at the front, Teacher Jason Yeh. You can take a look, it's open. You can follow me to try to understand more about me lah. Okay, all right. So I think blabbering enough. Next one. Okay, now I understand that you have heard of this event through Telegram, Instagram, or YouTube or what's not. Yeah, that's why you are here. In fact, if you were to go to these particular outlets over here or social media parts over here, Overmark is one of the tuition centers that currently appears there lah. So we have the multiple outlets here, and you're currently situated here to have a feel of what math teaching is like in general here lah. Okay, a lot of students, a lot of branches, 9 in particular, but you're just trying to keep it there and make sure our quality is there as well. Okay, quick one over here. Okay, 70% as mentioned over here is not just like ballpark number. We actually do have data, but I will share with you all if you want to. Okay, and also most of us, me generally as well from NUS, okay, so that we'll be able to teach you all clearly lah. Okay, not just from NUS, but to make sure that we are capable to teach you all. We have some of them are from MOE and Learning Lab. I do get my teaching concepts from them as well, so that I'll be able to teach you all better as well lah. Okay, and as well as this part over here, you may realize it's still a bit like gloomy, but it's still in progress. Okay, we do have multiple outlets whereby our learning environment is actually quite bright for you all to learn on. Okay, last part over here, quick one. Okay, so just to take note also, if you are overmarked student, okay, this is just one of the benefits that you have. We do plan for mock exams, okay. Unfortunately, for math, these two are out. Yeah, there's no science practical notes lah, okay, because there's no math practical. Okay, but we do provide you with weighted assessments, revisions, cheat sheets, or even after class consultations. I do have people actually texting me about 9 p.m. asking me to solve a question. I mean, they don't expect instant reply, but I do reply them straight away if needed to lah. So these are just an overview of Overmark over here. Any questions so far? Like what you want to know more about Overmark before I start for this session for today? No? All right, all good. If not, okay, cozy one. I just have two people for today. So let's get on with the content. Yeah. So some of them may be a bit foreign. Okay. Some of them may be a little bit special. But here's the flow of the lesson is going to be. It's going to be quite some back and forth at this point. It's not going to be, okay, here is how you do a question. So this question, we are going to do it this way. No. I want you all to actually have this particular thinking processes as we tackle not only this particular topic, but as the many topics to come along. Okay, for this one, maybe the first one, properties of circles. So what are we going to go through today? These topics are picked based on the demographics of the students that around here. So around Novena, I've actually checked through the syllabus and I realized that these topics comes into mind, which is properties of circles. After that, going to congruence and similarity and a little bit of maturation. So very geometry based because I have, based on my experience so far, I realized that geometry style of questions are really the pain points. Okay, because it's hard to see, hard to find out what you're looking for, and that's where I give you all the solutions. Okay, can? All right, so without further ado, let's just do a quick recap over here. First one, properties of circles. Now over here, these are just some theorems that I don't want to go through them because it should be embedded in you by now. But I just need you all to take note what are the things that comes along and remind you all when we talk about these theorems. Okay, first one, the chord theorem. What is it about? Okay, it's basically saying that if I have these two chords having the same length, okay, these two distances are equidistant as well. Long story short, it's just saying OE equals to OF, AB equals to CD. Henceforth, as a result as well, because it's cutting from the center, I'm saying that these two parts are also equal as well. Okay, so these two particular lines over there are actually okay, sorry for that. Just give me a moment, yeah? I'm just gonna put the worksheet in there so that whoever is there can download. Okay, for the rest over here, just take note. Okay, just give me a moment. Let me just send it in. My apologies for that. Okay, just give me a sec, yeah? Okay, for those online, I've actually sent it through the chat. My apologies for not sending it throughout. Okay, you should be able to see it now. Yeah, and you can annotate from there. Okay, so back to here, my chord theorem. This is really in summary what it means here. Okay, these two are equal, means these two are equal. Henceforth, even if I cut it from the center, these parts are equal as well. Okay, can? All right. Now, next one over here, perpendicular bisector. Okay, it's as a result from here as well, if you realize. Okay, if I cut through from the center, and it is to the chord, guaranteed, okay, just take note, reminder, this is just a reminder, it will be perpendicular, and again, it follows the particular property over here. Okay, so a quick one. Okay, and also as a result, okay, just a quick one also, if it makes sense for you all, anything from this point to the center over here will be equidistant because this is the midpoint. Okay, any part here will be equal. So these parts will be equal as well. So it can be AC to CB, or in fact, if I were to join it to these parts, okay, the green lines will be equal as well. Okay, these are just some examples that we can take note. Okay, but in fact, for this one, it's just AC equals to BC lah. Okay, so something you all can take note. So the green lines are just saying that they are equal lah. Okay, now, further up, I would say in terms of theorems right now, these two will be, starting from here onwards, this will be the most common. Why? Okay, and the abbreviations are important as well. Immediately, okay, if you see a tangent, sorry, this is not the tangent. If you see a tangent, if you see a radius, all right, immediately, standard way, tangent will be perpendicular to the radius, without a doubt. Always the case. Okay, so just take note. Sometimes if you see the diagram, if you spot a tangent, radius, straight away spot this down. Okay, so this is one common one we will need to take note. Okay. As a result as well, all right, if we have, in this case, tangent perpendicular to radius, all right, the other one, okay, this is just one tangent, but let's say I have two tangents joining to the same point. Take note, they are joining to the same point, yeah?
Okay, if they are joining to the same point, all right, I can straight away tell myself three things. One, all right, these two definitely equal in length. Two, this particular dotted line over here, it is actually the bisector. Basically, what it means is it will actually make sure these angles are the same. Note my color coding, all right? It will work out as of what the angle means. Basically, I'm saying AOT equals to BOT and ATO equals to BTO. Okay, so moving on, quick one. Now, next one's over here. Just a few more properties to go. As you can see, just 4 more before I go on to a question. Next one, angles in the same segment. Now, what it means to be in the same segment? Picture. Okay, when I say same segment, recall a segment is formed by a particular arc and a random dotted line here. In this case, a straight line, I would say. So if I picture angles in the same segment, where I picture my red color line, or the red color part, as the one of the segment, they are the same, and in this case, you can say my angles are at the same side. So this is one way to remember. Angles at the same side, okay, we say that they are going to be equal. And how to spot them? Okay, it doesn't really look like a butterfly at this point, but look out for the butterfly shape. Okay, where is this butterfly? Not really a butterfly, but yeah, just leave with it. In terms of math, your butterfly is going to be like this, like straight lines. It doesn't look like a butterfly, I agree. Where's the body? Where's the feelers? But just picture them as only 2 wings there. That's going to be your butterfly. Okay, moving on. The other one, how do we actually spot this one? Just take note over here. We know this property, but how do we spot? That's the main thing. This property can be spotted by noting the arrow shape. So in this case over here, my arrow heads. So if I have one arrowhead at the circumference, one arrowhead at the center. Okay, this will be more than enough to show that angles at center is 2 times angle at the circumference. There are many variants of the arrowheads, okay? Let me identify for you, in this case, at the diagram below, where are my arrowheads? So for the first one, okay, my arrowheads, one at the circumference, one at the center. Okay, you may wonder why isn't my angle the orange one here? Okay, understand from the property. You tell yourself, this one multiply by 2. Is it going to give you this size? Not really, right? You realize these two are almost equal. If it times 2, this should be way wider, right? So that's why over here, okay, in this case, my particular angle will be over here. So just picture the arrowheads in general. So over here, it will be this one, and this way, these arrowheads here, and these arrowheads here. So really looking out for the arrowheads will help you to understand better. Okay, and I know I see a lot of coloring, so you realize that for me, I love to use colors. But unfortunately, in exams, you cannot do so. So that's why I use your pencils to help you all. Okay, just 2 more to go, all right, before we go on to questions. All right, next one. This one, I won't say is a separate property. Why? Yes, angles in a semicircle. We know this angle is 90 degrees, but why? We can actually show from here. How? We picture ourselves, angles at the center. Trevor, can you tell me what this angle is? 180, right? Okay, Trevor, based on that, over here, 180 divided by 90, what's the angle? 2, right? Isn't it 2 times? Isn't it the same thing here? So you realize this one over here is not saying that, oh, okay, I need to memorize this, it's not from somewhere. But because this is 180 degrees, divide by 2, get to 90. So when you are doing questions, this particular mindset that comes into mind. why is the question asked this way? Why is the concept being asked this way as well? I want you all to slowly get that mindset in mind. And as we all go through topics, this is the mindset that I want you to take note. Okay? The topics here are meant for you to cover, but the purpose of this revision session is for me to bring into you the mindsets always when you encounter the questions, regardless of the topic. Okay, so last one over here. Okay, take note, third one. The third property can only hold if this is the diameter. If it's not the diameter, it doesn't work because it's not at the center. Diameter must cut through the center. Okay, this one you're aware. Last one. Opposite angles of the quadrilateral. This one, there is also another way of saying, if you all don't know what is cyclic quad, it's okay. This is what we call also angles in opposite segments. Why are they opposite segments? Using this line as an example. Okay. I have these two. You realize they are opposite. This is one segment. This is another segment. So that's why it works. Okay, so I know you all know the concepts, definitely. But I want you all to actually understand the concept behind, so that's easier for you all to absorb. Okay, or in this case, opposite segments, or what we call opposite sides lah. Okay, cool. All right. Okay, so I know all these properties are there, but the focus over here is when we tackle this question, I know when you see this, everything is written there. So what's the purpose of going through this? You may wonder. Now, it's not just saying, okay, please read through yourself. No, I'm not going to do that. Every question over here, from this moment onwards, especially for geometry, this one, write down. It is my own thinking process over here that I advocate when it comes to geometry questions, or maybe some weird questions that comes about. What is that one? Okay, I'm going to write it down. This one is a self-invent one, so if you heard it a little bit, it can feel a bit weird. What is this concept over here? I call this particular thinking process over here my reverse engineering. Now you may wonder, what are you talking about? What is reverse engineering? Because take note, when you engineer a particular product, okay, you are fixing it straight, right? Reverse engineer means you work towards the backwards process. What do I mean? In this case over here, okay, what I will do for these questions in general is assume what you are being asked over here is known. So what you are being asked, you know it. You pretend you know it. You don't know, but let's say you know. How's that helpful? This is where in terms of diagrams, it will be very helpful. Why? Okay, because then you can ask yourself, how does that work? Okay, I'm gonna just explain with a simple one marker question, or maybe a one marker that seems hard, but once I elaborate it will be clear. First one, usually in terms of descriptions over here, the angles given here will be enough to solve. Example, I want to solve for this particular angle. I don't know the angle, but let's say I know. I mark it down. Let's say I know this angle. So in this case, the orange color part, assuming what you are being asked is known. What other info is going to help you there? Now you ask ourselves, I'm only given two angles. 62. Does this 62 really help me here? It's a bit far-fetched, right? Away from the circle. So over here, let's take a next look. My 40 here. How, in this case, the only one that helps me is the 40. How does my 40 help me? If you take a closer look, very good, very good, Brandon, because of my cyclic chord here, and you realize, oh, ask yourself, if I know this, what is, in this case, other angles to help me get here? That's why if you read the working in the end, it focuses on cyclic quad or angles and opposite segments. So this is the thought process that I want you all to tackle from this moment on. Not just for any topic, not just for this topic, sorry, but in any topics in general. Okay, so that's why I take 180 minus 40, which is not 40, sorry for that, it's 140. Can you all change it for me? My apologies here, it's 140. Okay, and one good thing I will always want to do is I will actually like to write the angle here. 140 degrees. Okay, got this down? All right, so far? Trevor, okay? All right, Brandon, okay? Awesome. Okay, online side, if you're not sure of anything, just type in the chat because there's quite a bit of you. So yeah, all right. Any questions, please ask along, type in the chat, okay? Now, next one. Ask yourself, I want CDO. Okay, why is it this way? Check, where is CDO? CDO is not exactly drawn, but if I were to label my lines like this, take note, read it carefully. I know sometimes we read the question, then we refer to the diagram. CDO is this angle, right? Why is this angle 90 degrees? Anything from the center to the circumference is a radius, right? So this is a radius, this is a tangent. We know tangents are definitely perpendicular to the radius, therefore easy one marker down. Okay, so that's how I want you all to tackle the questions. Assume you know them. How do we do the question? Okay, last one. This is a little bit long, so just bear with me. BOF. Now, how do I get all these particular workings here? You may wonder. Okay, again, following the same thought process. BOF. Okay, so I want BOF. So BOF is over here. Now you ask yourselves over here, if I have this angle, what other angles will help me to get BOF? Okay, in this case, of course, CDO. Okay, that's one nearer one. And if you realize over here also, this will help me as well, which is this particular angle. Correct? That is tangent perpendicular to radius. Okay, able to track my thought process? So what happens? What is left to find is actually this particular angle here. But how? We backtrack. We know this is 90. We know this is 90. Take note, the question will always give you the angle. We have used this one. What is left is this angle that we have yet to find. Not yet to find. What is left is this angle that I've yet to use. So if I have this angle that I've yet to use, I know these two. I want to find this. What is one more angle I've yet to find here? Trevor, want to give it a try? What is one more angle you think will help me over here? Let's try. It's okay. Sorry? DOJ. Very good. DOJ. So very nice. Okay. Over here, I don't advocate like your answers must be correct. If it's wrong, we all learn together. That's the culture I want to advocate. Okay. So we want to find DOJ, which is DOF, same thing. Now we backtrack. If I can find DOJ, all will be good, right? What angles will help me find DOJ? Backtrack. What angles will help me find DOJ? Brandon, would you like to try? Okay, I understand that you can refer to the answer schemes, but I don't really want to go to that. Just try. You can refer to my diagram if yours is messy. Mine is a bonus, got colors on. No worries. If not sure, just say not sure. It's fine. No worries. It's okay. That's why we don't learn. So let's backtrack. Okay, so sometimes it's not just the properties that we have. DOJ, we need to find that, right? Backtrack. What angles will help me find DOJ? We have a 40 here, or in this case, particular, one hint. We have a straight line. So if I want to find this angle, will actually this angle help me then? And it's a straight line, right? Now, if I want to find this angle, it's not stated there because the properties of circles is basically in the properties of circles, but other properties like your basic geometry, all this must also come in hand. Now, if I want to find this angle, let's check what other angles will help me. ODH, yes. But if you look at the diagram, you may find a lot of things to find there. But if you actually look closely, do I know ODH? Do I actually know ODH? What is ODH? Very good. Why 40? One thing is, I know just now you all were looking at it, at the question, but just now when you were staring at the diagram, did I tell you the answer straight? All right. It's all really relying on from the diagrams to backtrack. So once you realize you have 40 and 40, all this we can find. We can find this, we can find this. This one over here is what we are looking out for. Angles, sum of chord. Yes. Arrowhead can also. Very good. Nice. Good approach there. Love it. Okay. So another approach there is that you can use the arrowhead. Good job. Yeah. Even better. So sometimes the solutions are written there. It's a bit long-winded. You have improved my solutions from there, which is very good. Yeah. That's my arrowhead. So 40. This is 80. So over there, you realize from my solution set, I wrote what? Exterior angle of triangle. But you have improved it even better. One step. So I don't even need to know this actually. So that's a very good approach. Yeah. Keep it up over there. See, any approach works. Okay, just that it has to be accurate and you are working backwards from there. Okay, so what Trevor mentioned was actually the reverse part where I have 40, 80, and then what happens? You have my figures here. Angle sum of chord, that's why I have that particular working there. Okay, basically listing it down. Okay, so maybe let me share the working to the crowd. Alternatively, to find DOF, okay, you can write this down. It's actually 2 times, in this case over here, what's the angle? 2 times DHO. Okay, that is the alternative step. This one, there's nothing wrong with the notes here. It's just saying an alternative step that we can take. Okay, and take note for geometry, we must write the reason. Angles at center equals, write in abbreviation 2 times angle at circumference. Okay, so very good job in identifying the approach there. I really love it. I really love it. I really love it. Awesome. Okay, then you realize all of the working holes from there. Refer to the diagram. Okay, I'll give you a while right now. The workings, once you look at it, I want you to refer to the diagram. Give yourself some time to actually look at it and say, this is how we actually get this down. Okay, I don't want you to just look at the working there and be like, oh, okay, I'm just going to accept it. No, we are not accepting anything. Okay? Can So we know final answer in this case here. Always remember angles found, we annotate 38 degrees. All good? Can Okay, now last one over there. Same stuff. FJD. So where is FJD? FJD is over here. Okay, now over here we ask ourselves, if I want to find that particular angle, okay, what other angles will help me find FJD? Okay, so if we try to backtrack, this one might be a little bit harder, but it's all right. Okay, we can backtrack from there to see what angles will help me. Okay, so FJD looks like an angle that is really sandwiched here. A little bit hard to see. But if we take a look, FJD is a triangle, right? So if you look at the workings there, okay, can we actually say, if you think about it, if I know this angle, and if I know this angle in light blue here, let me use yellow. No, let me use gray, is too light. Sorry, this angle, this is too bright. This angle, won't I able to find FJD, which is this one? So take note, our goal is to find this. If I know this, my job is done, right? Okay, now let's backtrack. How do I find all these particular angles? Okay, let's check. First one, a bit hard to see. Okay, first one, let's identify BDF. Okay, usually a diagram is drawn like that. We don't draw additional lines. Always remember, also another hack, the other angles that you have found, in this case over here, are always going to help you in the later parts. So let's check. A bit hard to see. BDF. Try to see what angles are going to help you. Okay, in the earlier part, you realize my first step is actually angles at center equals 2 times angle at circumference. Okay, so you realize once we take a look from the working, this is where you have this butterfly. And my arrowheads are exactly here and center. Sorry? Yes, very nice. So it's 19 here. Job 1 done. We need to find another one. Next one, DFH. How do we find it? Or in this case, OFD. Okay, if you take a look at my diagram again, we have found just now this is 80. This is OD. This is OF. Same style. It looks like a what triangle? Isosceles. Then we can work it through. You may have different ways to find, but this is a first overview to tell ourselves how we can backtrack to get all these values here. So we have 50, we have 19, focusing in this case on my blue color triangle. Blue color triangle here. We are then able to find this angle, which you look from the weighted workings there. Sum of angles, 180 minus 50 minus 19. Okay, can see? All right, I know it's a little bit of a stretch, but that's where I would say if you write down on your side as we do the questions along, it will get better. All right, cool. Let's try some hands-on together. All right, first one. Looks a bit complicated. Okay? In the diagram below, there are a lot of things. But, okay, one thing to take note as well, all right, when we see parallel lines, all right, we know things are going to get a bit more fun, okay, because with parallel lines, more properties can be found. And also for this type of questions, okay, always tell yourself, don't need to find new angles. It is always related to the only angle that you have, which in this case over here, angle ADC is 54 degrees. Okay, the congruent part, okay, is for later, but just inside, sometimes mixed concepts can be mixed. Okay, first one, find angle CAD. Again, the same concept. CAD is this angle, right? If I have CAD, what other angles will help me find CAD? Trevor, give it a try. ADC. Do we actually know ADC? You see that? I know the angle. We are just backward processing. In a way, your workings is done. But how to write? This one important. Knowing the workings is one. But in terms of writing it out, your teachers are going to be very particular. So the way to write is this. Okay, we know first one, angle ADC is equals to 90 degrees. We must write the reason. Right angle in a semicircle. Now, don't think otherwise. Right angle in the semicircle is really just like this. After that, following up the next reason, CAD is equals to 180 minus 90 minus 54 degrees. This is angle sum of triangle. this is equals to 36 degrees. Okay? And you realize, unfortunately, they are a bit stingy. So your mark actually comes from here. They are a bit stingy. You may wonder, what, one mark, why like that? Like this. Just need to write it in this manner. It's enough. Okay? Now, once we get the angle, I urge you all to write this down. Okay? Then afterwards, let's try. Okay? Brandon seems like you're on task. AOD, come. With the angles you have.
First angle and first triangle will be as an isosceles triangle.
Okay, AOD is an isosceles triangle.
Find it between 180 degrees minus 236.
Very good. Then after that, you do the, what's your next reason after that? Isosceles triangle. So to find this, right? Then after that, I believe you did the straight line. Okay, because take note is AO. AOD. Okay, yes, AOD. Very nice. Yeah, very good over here. So I'm finding AOD. So in this case, isosceles triangle. Very good. So in this case, I will state the reason first. So you realize because in order to find AOD, I need this angle. So always have the proper reasons. So this is 36 degrees as well. You have to write the reason. What is the reason? First, you have to state ADO is also 36 degrees. A little bit troublesome. Okay? What is the main reason here? This is base angles of my isosceles triangle. Okay? This is why it's 36 degrees, because it's the base angle itself. After that, that's where you actually take the angle sum of triangle. So over here, I have angle AOD. This is 180 degrees minus 2 of 36 degrees. What is the reason here? All right. No matter how simple the reason is, must write angle sum of triangle. Okay, so 180 minus 72, that's going to be 108. Okay, but in fact over here, I would say there is another step that we can get it straight instead of using this. I want you all take a look. There's another way of getting that. Anybody wants to try? There's another there's another way. I can get it in one step. I give you a hint. It's a property of circle we have. One of the properties of circles we have touched on. One step. How do you spot that? What did I tell you just now? What do you see? You see arrowhead ma? You see arrowhead immediately work already. Again, your method is correct, but we always want to work for alternatives to see efficiency. Okay, so you see arrowhead, work already ma? But it's fine. Your method does work, it works as well. Ultimately, we all get to the same answer. I'm not going to fault anyone. Okay, following up. Okay, so this question is really to find out your angles. Next one, CAE. Let's check. Now that's where things get a little bit more fun. CAE. Where is angle CAE? It's this one, right? Okay, now ask ourselves, I want to find angle CAE. What angle will actually help me find CAE? Sorry? No, just say it's okay, it's okay. I just didn't hear you properly. CAD. All right, very nice. So we have found one of the CAD. Okay, and in fact, if I can find CAD, which is given, and where's the other alternative angle that I need to find? CDE. All right, okay, CDE. I can get my job done, right? What do you say, CDE? No, it's correct. But what do you say? I give you confidence. Very good. Angles in the cyclic quad, opposite segments. Okay, I didn't give you the answer. Now, the only key thing is, if you want to use that first, I need to find one key angle. CDE is this one, ma? What I need to find? I need to find this one, which I have. I need to find this one, right? How do I find this one? 180 minus 54. Sorry? Okay, yep, that's 36. That's good. Okay, but we want to check 180 minus 54. How do you get that down? It's okay. We all rectify. Okay. I got you. I got you. So let me check your thought process. You are using one property. Can you tell me what's the property you're using here? So I know you all know your properties. You all know how to say. Very good. You are using which property? Parallel lines got three. Uh, three. Which one? Got three type. So in this case, do you use what he used or do you think of another way? Oh, okay. So unfortunately, I know the names are very annoying, but you have to write it down because they will penalize you from there. Okay, why is it 36? It's either your side, if you use interior angles, okay, where you have this shape. Okay, so let's just go with the thought process since we are at it. Okay, so in this case, I want to find which one? What's the angle name? ADE. Okay, so I have ADE. So ADE is equals to 180 degrees minus 90 degrees minus 36 degrees. This one is your C. Okay, basically, if you see a C shape, that is where your interior angles comes in. Okay, and the thing for interior angles, if it happens, we must actually say the parallel lines. If you don't say, that's it, cannot, doesn't work. Okay, so 180 minus 90, I forgot to subtract a 54. Give me a moment, let me subtract a 54. Minus 54 degrees. Okay, this is gonna give me 36. Sorry? All right, let me give you a moment. 54. Oh, 54, 90. Yes, I subtract another 36. Sorry for that. Yes, so this is the 56. Thank you for taking note. Okay, so take note from the diagram. It's just 90 and 54. Okay, so ADE is 36, yeah? After that, all right, what property are we using to find our angle CAE? Backtrack, what property? This one only one way? Brandon, what property here? Yeah, CAE. You have mentioned this quite a few times. Something about a quad. Yes, where's my cyclic quad? If you take a look, okay, this is the angle we have, right? Okay, or in fact, this is the angle we have. My cyclic quad is actually here. All the parts must join the circumference. Can see? You all see that? All right, just make sure my cyclic quad, all the points are at the circumference and the angles that I'm looking for is not just the green one, but also in this case, if I were to overextend, it's this blue one here. So it's the blue and the green gives me 180. I know this is 90. I know this is 36. Okay, so that's where we write it down. We are going to say 180 degrees minus 90 degrees minus 36 degrees. This is angles in opposite segment. Okay, CAE is 54. Okay, same thought process. Let's carry on. BAT. Now, where is BAT? BAT, do you realize is... Okay, I'm gonna use different colors. Let me erase everything here. No, let me not erase everything. BAT. BAT is this angle here. Okay, so I'm gonna highlight it nicely. BAT is this angle here. Now ask ourselves, if I want to find BAT, what angles will help me find BAT? Okay, think with the properties and link them. Any idea? Just try.
think you know BAF.
BAF, all right. Okay, we need BAF and is what? Sorry? Oh, sorry? BAD. Unfortunately, even though it looks like it, cannot assume. Because if you want to say equilateral, we need to prove that the sides are the same. In this case, it's not. They never say, cannot assume. I know we are inclined to say that they are equilateral, but unfortunately, no. But in a way, talking about triangles, I give you a hint. We talk about BAF, right? Okay, BAO, BAF, right? We need to know that. Okay, I give you a hint. Okay, this one will help us. When we talk about congruent recall, okay, which I'm going to revise later. In this case, what can I say about the angles? They are the same, right? So specifically BAD, or in this case over here, specifically, I know DAF. If I know DAF, what is my angle BAF here? Because they are congruent lah. Okay, so that's one thing down. This is the hardest part. Can see? Yeah, so that's why all these keywords we need to take note lah. Okay, online side, if there's any questions, okay, feel free to type in the chat, yeah? Okay, now, we have gotten the hardest part down actually. Now, next one. I just need one, besides BAF, one more angle that I need. CAT, because, sorry, carry on. Very good. Materials all done. So backward from there. Can Okay, so this is what we have. And we write what you all have told me down. So I have OAT or CAT, doesn't matter. OAT is 90 degrees, tangent, perpendicular to radius. Next one, I am going to use that these two angles are equal. Okay, even though the question says it's congruent, we must still write down over here as a reason. Okay, then after that, you realize BAT is just make up of adding them up. Okay, adding them up, no need to write the geometrical reason. It's just adding. So it's not a geometrical fact, it's like a truth. So no need to write reason there. Okay, cool. Can Okay, let's move on. Last one. ADT, same concept. Let's try. ADT is this one. Okay, let's try. This is ADT. Okay, ADT. Okay, I'm going to use black. ADT is this angle here. If I have this angle, what other angles do I need? No, sorry. ADT, sorry. ADT is here. My bad. If I want to find this angle, which other angles will help me? Let's give it a try. Trevor, come. Height. Sorry. All the angles in the kite. Oh, okay, you're looking in the kite. Okay, can. Okay, interesting way of looking here. Then after that, okay, take note. Okay, I know what you say is a kite, but can. Okay, you want to look at it as a kite. Okay, carry on. I get where you are at. Okay, carry on. Okay, all the angles in the kite minus this. Then I think you're looking at this and this, right? But take note. Oh, okay. What is this angle here? I get you know it's a kite, but just to confirm with you, what is this angle here? Because you say kite, ma, you say minus this angle. So I need to know these two angles, ma. They are? No, I'm asking you, I'm not questioning. Sorry? The orange one? I think no, this is not part of the kite, okay, so this is 36. Okay, I hear the correct word. You're looking at this angle, which is 90 lah. Okay, so sometimes you want to label the angle, you must tell me the three things lah, so it's clear. In this case, OAT lah. Okay, but I'm glad that you know it's 90. Interesting approaches I'm hearing from you are very good. Okay, so OAT, this is 90, this is 90. And yeah, okay, very nice. Okay, So over here, 1 mark, this is just angle sum of quad, which is ADT 360 minus 108 minus 90 minus 90. Okay, this is because angle sum of quad. Okay, in fact, right, the answers I have is different from what you are thinking. So, very nice job over there to actually think of alternative ways to do. Okay, then you may wonder, what is your way? You keep saying your own way, right? So over here, remember, my mind is like a student. Properties of circle. So I must use properties of circle. So I take a look. Okay, properties of circle. Okay, and then maybe I only can see triangle. So I only can see this triangle here. This is my thought lah. Okay, doesn't have to follow. If you take a look, ADT is there, right? If I know the black color angle, I can also try to know this angle, right? One thing also, tangent from external point, these two things are equal, right? AT and TD are equal, right? If I know the angle, I also know this angle. Do I know these two angles? You tell me this is 90, ma? This is 36. You can find this. So there are many ways towards finding, but in this case, I'll follow your thought processes. Okay, any questions so far? So this is one style of questioning that we can get to, and let's proceed on to the next one over here. All right, let's proceed on to the next one here. Okay, so right now, I think you guys get the drill already. I'm going to quicken the pace a little bit, just a little bit. Okay, next one, you realize same style for A and B, but you realize for the last one, it's a little bit different. Why? Proving. Okay, what I mean? The C part lah. It's a little bit on proving. Okay, first one, ACD. I think this one, you all can answer to me in, I think, a few seconds. I want ACD. Okay, what angle will help me find ACD? Okay, in this case, AOB. Okay, AOD, yes, but in this case, if I want to find AOD, what other angle will help me find AOD? Okay, ABD. And in this case, do we know ABD? So I know you're picturing 2 times, then come here, but actually we can solve it in 1 step. But it's fine. It's fine. It's okay. You got the thought process down. Why am I to fault you? Okay, it's just a bit long-winded, but over here, you realize if I look at this butterfly, okay, this is just ACD is equals to 27 degrees because angles in the same segment. Okay, in this one, you are doing good. So I will just go a little bit. You know what? Never mind. I'll just leave it here. I'll go a little bit quicker. Okay, following up, next one. Okay, can Okay, next one, let's try DAH. Now take note, DAH is my angle here. Ask ourselves, I want to find DAH. What other angles will help me? Okay, so draw lines. DAH. Trevor, what other angles will help me? We call the properties you have. Check DAH. OAD, very good. And in this case, we know, okay, this one I help you out a little, but I think you all can figure it out in a while. Because OA, OD are the radius, they are equal. So in fact, I can also know this. Yes, isosceles. And in fact, if I know these 2 angles, what other angle can I find? Yup, tangent, in this case, to find. Very nice. But specifically, right angle. Okay, so right angle here specifically, OAQ. Yep, OAQ is a right angle. Very good. So we write that down first. Okay, so we write that down first. So we have OAH or Q, doesn't matter. I'm just using the small shorter line. Okay, tangent perpendicular to radius. Then afterwards, let's backtrack. Okay, I know this is 90 degrees. But I will backtrack again a little bit more. Okay, next one. What angles do I have to help me find? I know if I want to find this, I need to know this. What other angles will help me find the orange color one? Very good. Okay. Very good. See, in unison some more. So now we can craft the working out. So AOD, we know it's 54. Okay, because angle at center equals to 2 times angle at circumference. Okay, then your working is to find, as you all have mentioned, OAD. OAD here is 180 degrees minus 54 divided by 2. Okay, for this one, I'll specifically write two reasons together. Okay, why? Angle sum of triangle for the 180, my base angles divide by 2. Okay, then that's where you all tell me and craft my DAH. Okay, nothing really special. Even though the questions are different, the thought processes are always all going to be the same way. You are really trying to find out what are the angles that you have previously in this question, and we relate back to the question here, question part here. Okay, can I all good? Okay, write it down before I move on. Okay, awesome. Okay, all good. Now, last part. Now, for proving questions, specifically the first style. If you want to prove a geometrical property, we are always trying to relate to the properties we have learned before. What do I mean? Specifically for this question, parallel, remember I told you about 3 things that we need to take note? Okay, when we say parallel, over here, guaranteed 100% of the time, we are linking to 3 specific properties. Okay, these are your Z, F, C. Each one of them corresponds to each one. Okay, so just now we use the interior, but now I'm gonna bring in their friend, corresponding, and alternate. Either one of them will help me show. What do I mean? BA parallel to FG. So I'm looking for these 2 lines, right? BA, FG. Now over here, how do I show? Recall my properties. What other angles will help me to prove in this case or show whether they are parallel? There's one angle we have yet to find. DGF, right? DGF, what's the angle? You shout out the number? Or you can use your call. Sorry? Sorry? Oh, sorry. Yes, 27. Now, if we have 27 here, are we actually showing that they are parallel? But we want to show parallel. Cyclic quad is to find the angle. But I want to show specifically these 2 lines are parallel. So, look at the diagram label. Sorry? Yes. Yeah, so specifically BDG is a straight line. So does this look familiar? So always remember, just now what you told me is finding the angles very good. But in terms of proving, we need to relate back to ZFC. Parallel, it will always work this way. So that means just now we found DGF in the first step, which is good. So 180 degrees minus 153 degrees. This is because angles in opposite segments. This is 27. Okay, this is my Z shape. So how we write our reasoning? Since these are the same, okay, understand that there must be a word converse of, but as long as you tell me the angles, it's fine. By alternate angles. Because of alternate angles, that's why parallel. This is okay. Okay, online side, maybe I check on you all. If you're still there, just drop me a thumbs up so that I am aware that you are all still there with me. Awesome. Thank you. Thank you for the part. Awesome. Okay. Brandon, okay? Travel, okay? Okay. So now we are getting to the engine here lah. Okay. So let's see how we can get on a bit quicker. Third one. Okay. I'm gonna quicken the pace a little bit So since we are here. So state your reasons clearly. Find angle. First one. ABD. So let's backtrack. ABD Find all your butterflies and all your stuff. ABD is here. If I want to find angle ABD, which angle will help me? If you take a close look, think about it. Okay, find your butterflies and all the angles that is supposed to help me. First one here, a bit too far. DCE. Yeah, that's it. The reason is? Or you tell me the angle. What's the value of the angle first? 30, very good. But now you're thinking, what reason? I know. The reasons are the most annoying. But I can tell you you all get the value first. Very good. Okay, so what is the reason? You all know angle ABD equals to angle ACD or DCE, doesn't matter. Okay, reason over here, angles in the same segment. Okay, and we know this is 30 degrees. Okay, you realize I'm drawing lesser and it's less colorful. It's a good sign because you're utilizing it well. Angles in the same segment. For those who are wondering, my butterfly is here. Don't ask me why does this look like a butterfly. Yeah, because of the wings, I guess. Okay, now next one. Angle BAC. Okay, let's check. Angle BAC is this angle over here. So BAC. Okay, ask ourselves, I want to find this angle. Okay, which angle will help me find BAC? Take note with the angles that I know, keyword, the angles that I know. This one a bit of a trap. If you go one way, it may be a bit longer with the angles that I know. Try. My class very vocal one. Just shoot. Okay one. Sorry. AED. AEB. Okay, we can try angle AEB. Let's backtrack. That means this is equals to this. Which other angles will help me find AEB or in this case DEC? Because vertically opposite. We need to have the values that we have. So take note when we solve these questions, always ask, okay, does the question info help me to actually acquire these values? The thought process is correct. I can use this triangle. I can vertically opposite. But are the values there enough to help me? Okay, in this case, I'll backtrack to tell you a bit hard because we need to know this one. Okay, don't have so we backtrack. Okay, come. Any other roots? AD equals to DC, never say. Question never say cannot do anything. If got say, I will tell you good news then we can do this. But you're on the right track. Something about isosceles, but in a different way. You're looking at the isosceles in a different way. There is one way where we can guarantee there's an isosceles triangle. Come, try. It's okay. Try. Shoot. AC equals to BC. Cannot. Never say. Why? Here, question never say. Unless you can prove it to me. If question never say, don't assume. Okay, let's backtrack. We slowly first. I think you're all going too far. Bring your back. You bring your back. Take note. We need to find this angle. Ask yourselves, which other angle will help me? Key thing over here, you realize I have used 30 already. So ask yourself, how can the 74 or in this case the 24 help me? Okay, let me help you all. Okay, let's say you look at the 74. which means I need to know what this angle is, right? Are there any info helping me to find the green color angle? You have to agree with me, think first. Sometimes the question I ask doesn't means the solution is correct. Okay, you all wonder thing, right? A bit hard, right? Then that means, sorry? The butterfly. Okay, so that means the butterfly doesn't work lah. Okay, backtrack. Now, one left is the angle left 24, right? Okay, because the 74 somehow we thought straight line, wow, can help. But doesn't help me. Let's try a 24. With that 24, what can I get? Okay, I want to try to link this angle. Sorry? Okay, come, you say you see it, tell me. COB. Wait, which one? Lai Liao, come, shoot. Very good, okay, because of my radius. Come, share your next one. Are you very excited to share? Come. Very good. Awesome, guys, awesome. And then we can find BOC, right? Because you tell me isosceles. Isosceles means this one is 24. Then all these flow through. Good job, guys. Good job. 24. Then what working flow already? Triangle, isosceles, pump. Done. But how to write? Correct? Key thing is how to write. Okay, so sometimes you'll get excited. Wow, you'll write the working. But unfortunately, you'll never write the reasoning. I think your school not so particular in terms of... Your school is not so merciless in terms of subtracting marks. What do I mean? If you actually, let's say, you very excited, wow, chiong you write like this. Then after that, you do this. Let's say if you don't write the reason. What they will do, they will still give you the mark, but depending on schools, what are my experiences so far is that out of the whole question, they deduct 1 mark because you never write the reasoning. So remember, your reasoning comes here, angle, sum of triangle, base, angles of isosceles. Okay, the other one, angle at center equals to 2 times angle at circumference. Okay, so you must write the reasoning down. You got it? Okay, let's try. Okay, can I write the reasoning down as well? Okay, take some time, look it through. Okay, let me move on, yeah. Next one, angle ECO. Backtrack. I want to find ECO. Okay, always remember, I like to label the thing first. ECO. ECO is this one. So this angle here. If I have angle ECO, what angles will help me find angle ECO? What angles will help me find angle ECO? DCB. Okay, yes, that means I need DCB. Okay, now I need to know this whole angle DCB. Very good. So if I have angle DCB, what angles will help me find angle DCB? Okay, I'm checking on top process, and I will say you're on the right track. I give you a hint. Don't wander too far. Wander with the angles that you know or you haven't used yet. Always remember that. Or in this case, in the questions, wander with the question parts you haven't touched on yet. Give you a hint. We have used the 30, right, to find this. That's out. We have the 24 to find the required angle. That is out. What is one angle we haven't used yet? How does the 74 help me? From there, what property do we use? Not the arrowhead, but take note. Okay, all right. So a bit hard to see, but from here is really true knowing your properties well enough. Look big, look small, see what y'all can get from there. Okay, so I have DAB is 180 degrees minus 74. This is adjacent angles on a straight line. The word adjacent must be there on a straight line. Okay, this gives me 106. After that, you want to find ECO is really taking all the angles that you have. Okay, because angles in opposite segment or cyclic chord. (20 degrees). Okay, can? Okay, let me go off first. Any questions so far? All good? All right, now last one in terms of proving. All right, before we move on to one more question where I'll just briefly go through for you all. All right, W is a point on the same side of the major segment. It sounds like a mouthful, but okay, we recall what's the notion of a major segment? Major means big. Segment formed by the chord. So if I have my chord AD, the major segment form will be this part here. Okay, they tell you AWD is 45 degrees. State whether the point lies on the circumference, outside or inside. For that kind of questions, okay, what I want you all to do is, you all realize when you all touch on the properties, all of them are on the circumference, right? So what I want you all to do, not sure of anything, you assume the point is on the circumference first. Assume, I'm not saying it's true, you assume. After that, form my angle AWD. Okay, this is not a curve. Assume first. AWD. Okay, from there we check whether it is possible to be on the circumference. It tells us AWD is 45, right? Now, just by one look, or in this case, where you have to look a bit deeper, I can say, okay, what do you all notice? Is it on the circumference? Not, right? Okay, immediately know why. Okay. Okay, one way is this, but that cannot be an accurate one to be true. Use the properties. We must use properties to substantiate. It's not, okay, I'll give you a hint, it's not, but not because it's too small. Okay, we try, take note. AWD. Is there a particular property with the angles that I've known? I can show directly. Sorry? In a way, yes. You cannot assume it cuts through also, that's one. But doesn't cut through O, doesn't matter. Okay, the line can cut through O, never cut, it's okay. Okay, but I want you all to see this a bit hard, so let me finish up here. You all need to be familiar lah. Look out for all the butterflies and all the cyclic chord. If it is in on the circumference, my two angles have to be equal, right? But are they equal? You have to know and get used to the properties from there. So therefore, your reasoning will be AWD is equals to 45 degrees, but it's not equals to 30 degrees. So this one, you really actually have to know your butterflies and from properties from there. Okay, and to prove it, okay, it's really by angles in the same segment. Okay, we know it is not on the circumference. of the circle. And in this case, one thing to take note also, my angle is bigger. So if a picture to have a bigger angle, will the point be closer? In this case, what I mean, will the point actually be inside the circle or outside my circle in order for my angle to go? If you picture, will it go closer or further for my angle to be bigger? Closer, right? So inside. So that's why, how to compare? All right, we can say okay, so one thing is we assume that it is on the circumference first. Okay, because all our properties are usually on the circumference. Okay, all right, all good? Can any questions? Okay, now let's move on to the last one before I move on to the next topic. Okay, so over here, this is another proof question. And you realize, okay, sometimes it's hard to see, in this case for this one, explain why it is possible to draw a circle. What we can do, we draw a circle out to visualize. It is not really my circle, but we draw a rough circle to visualize. Okay, never mind. You know what? Let me draw a not so nice looking circle. Now, if I want to say this is in the circle, right? What property straight away comes into your mind? If cyclic quad, your favorite, right? All 4 points touch. So if cyclic quad, what is the best way to show? Opposite angles is 180, right? Whichever way, this way or this way. So refer to the diagram and see how we can backtrack. 36, one way we can look, this is also. Then after that, we can work with this angle, subtract. I'll do the math, 108. After that, there's one more missing angle. This one, right? What is the angle? Straight line, so 180 minus 121, this will give you 59. Then after that, you ask yourself, does these two add to 180? Do the math. In fact, they do add up lah. So really is knowing your circles part and how we solve from here. So how we craft our working again? ADB equals to ABD. This is base angles of isosceles triangle. This is 36. After that, I have DAB. This is equals to 180 degrees minus 36 minus 36. Refer to your triangles, which is angle sum of triangle. This is equals to 108. After that, we have DCB, which is not DCB, sorry. We are finding, okay, we don't need to find the 108 actually, my bad. Okay, my mistake, I was too engrossed in finding all the angles. So I'm finding CBE, sorry for that. Okay, so I want to find CDB is equals to 180 degrees minus 121 degrees. This is because adjacent angles on a straight line. Okay, this is 59. Okay, we just need to work out these two angles because since the two angles you are working with, ADC plus ABC is equals to 36 plus 49. Okay, let me work with 59. Okay, because I wrote ADC first. Okay, 36 plus 59 plus 36 plus 49 This is equals to 180 degrees. You all love the cyclic chord property. So my angles in opposite segment or cyclic chord. How to write the conclusion? Copy and paste the statement. This is enough. So copy and paste. It is possible to draw a circle that passes through A, B, C, and D. Okay, so this is one way whereby we can actually craft out and make sure when you write your conclusion, we must write this out. The 3 dots. Oh, that one is, oh, the dot, dot, dot. Okay, that one because you're writing a reasoning scene, so no need. Okay, but if you are afraid, okay, the scenes actually shows your dot, dot, dot already. Because this, there 480 by angles in opposite segments. But I'm replacing it with scene, so it is the same meaning. Any questions? Just ask. Can okay. If not, I think I spent quite some time. What is adjacent angles on a straight line? Okay, so adjacent angles on a straight line, okay, just a quick recap, is two angles, they are next to each other on a straight line like this. Okay? That's why it's 180. Just now it was 121. That's why the other one is 59. Does it make sense, Gwen? Yeah. Any questions or see? Okay, can All right, let's move on. Next one. Congruence and similarity. Now, the hard part is not applying your congruence and similarity, it's the different tests lah. Okay, so in this case, for a different test, let me just roughly brief through. First one, you have your SSS. So you need all three sides. Second one, ASA, or in this case, AAS. The orientation for this doesn't matter. It can be ASA or AAS. Doesn't matter. Both are fine. Third one, SAS, but however, this one only one way. Must be side angle side. Meaning, my angle has to be in a way, sometimes they call included, but it's a bit messy. So you can say, in layman terms, it has to be sandwiched between the two sides. So if you take a look at it, my angle, if you note here, it must be sandwiched. With my two sides. Okay, I would say these three are mainly used. Fourth one is right angle hypotenuse side. Basically, you need a right angle hypotenuse, any side is enough. Okay, so main important thing that I want to emphasize for this one is this particular part must be included. SSA. SSA is cannot. SSA is for similarity. No, SSA, no, cannot. Because take note, SSA, you have one side, you have one side, you have one angle. Okay, the other side can go very long. Okay, let's say SSA lah. I can have one side that goes this way. Okay, let me use an example why SSA cannot lah. SSA, right? This is one triangle. However, this side, I can shift it such that it's here. And we know these two are not the same. I can have this triangle, I can have this triangle, they are not the same. So SSA cannot. Okay, just a quick way to show lah. Okay, any other things why you're not convinced? Okay, if you need more detail, I can go to you lah. But take note for this one, it must be SAS. Die. Must be SAS. As I mentioned here lah. Must be the included angle. Okay, following up, similarity a bit loose. In a way, you realize two of the tests are almost the same. One of them is a bit different, which you realize you can actually derive from saying, Oh, similarity, I can be a bit loose. I can play along with the sides as long as the shapes are the same. Okay, think of it. How does SAA test come about? AA is basically AAS by get rid of the side. So it's really related to a congruence. And that's how you get your AA. Okay, but this is how you want to link, if you were to link it accordingly. Yeah, correct. But we do AA. Why? Do we actually need to prove the third angle? That's why AA enough lah. If you write AAA, I'm not too sure whether the teachers will fault you. But if you play safe on to write AAA, I'll give it to you. It's just redundant. Can? AA doesn't matter, to be honest. For me, I mean, no difference lah. So depending on how you have been actually taught in school so far. But usually AA is enough. Okay, can? All right, quick one. Okay, naming, very important. A lot of things to do, but in summary, make sure you follow the direction that you are labeling. Example, if you want to show AC, must be AC. It follows XZ, so XZ. If you actually write, this is a bit weird, but if you actually write, and I will say blatantly, stupid as well. If you write this in a congruence and similarity question, wrong. Cause never follow convention. Though they are the same, but in congruence and similarity, this is wrong, which applies in angles as well lah. Okay, so make sure your naming convention either all clockwise or anti-clockwise. You follow one. Okay, okay, can as a result as well, roughly as well covered in terms of properties of circle, you must justify, basically in your brackets lah. Even if it's given. If the question tell you it's given, must write. But just state it's given. A bit weird lah. Like, you give me already, I still need to write. Walao, said waste time. Just think of it this way lah. You are writing an answer scheme for the examiner to understand who is waking up very early in the morning to mark. So sometimes very blurred. So just leave it to them. Bracket given. Okay. Second one also, common side. Okay, just mentioned as a common side. Even though it's there, still have to write. Third one also, same thing, calculated angles. You just need to take note of the angles you need to write. Okay, this is the same as your properties of circle. Similar. Okay, after that, look at it as well, common reasonings. Okay, just now what we touched on. Okay, we have your interior angles, alternate angles. Okay, where Gwen asked me what's adjacent angles, this is adding up to 180, and the more common ones as well. Okay, number 7, if you all forget, just in case it looks like an inverted flag, is saying this lah. The exterior angle is the sum of my two interior angles. If you all need a refresher. And it must be opposite if you all need a refresher. All right. Okay. Looks familiar. I hope it does. Okay. All right. Let's push on. Now, in terms of congruence and similarity, first things is, okay, we talk about the ratio. In this case, the ratio here, we need to focus on the corresponding sides. They share the same ratio. Okay, what do I mean? Over here, you realize the cones are similar. As a result, the ratio will be the same. In this case, this one and this ratio will be equals to, in this case, this one and the ratio here, which follows exactly with 25 over 15 equals to 10 over small cone. Must be corresponding. Sorry? Volume, not same, similar. Similar. If we talk about volume, what's the volume ratio? I will touch on it in a while. You mean the formula is the same? Same, but different. Okay, I think you're asking that, right? Formula same, but different. For length is like this. We're going to go on to that. area is the same thing, but you think about it, we square. Why? All your area formulas cm square, meter square. That's why square. So it's the same stuff, but square. Okay, because it's a square, this is also 2L, if you may wonder. That's why we can do this. Last one, volume. This is where you go on to. If it's volume, you'll be same thing, but cube. Y. Cm cube. Meter cube. That's why cube. And then if you want to reverse the process, if you square, you square root. You cube root. Okay, and take note, it applies to the ratio. You don't square the length. Whenever we are doing this, we are applying to the proportion, the ratio. Okay, you can link to this proportion. Okay, all good. Now, what is one annoying thing they can mix for congruence and similarity? All right, is if you take a look at the question there, this one. Okay, help me change some stuff here. Sorry for that. A, this is B, and this is C. So sorry, help me do the corrections on your side. Okay, now over here, one thing to show similarity, right, is as such. Okay, sometimes when you put similarity, we don't know where to start. And you may wonder, sure, what is this thing you have drawn? Okay, because, okay, when you prove similarity, this is how the order is written. So one way to help yourself, you order the vertices in this manner. A to Q. B to R. C to C. Once you order in this particular manner, you realize we can find the angles easily and how we want to prove. Okay, this one, they are just using two angles. So any two angles from the diagram will be enough. So for my case, I use these two. First one, as you can tell, common angle, though it's the same, still must write. Okay, which is this one. Must write. Okay, then after that, just another angle you choose . So I have ABC, which is this one. I have QRC, which is this one. You take your pick. Okay, if you tell me you want to use CQR and this one, also can. You take your pick. Common angle is basically the angles that are exactly the same. A, C, B, Q, C, R. They are exactly the same. That's why common angle. Given cannot, because the question say got the thing. If they say given, okay, good question, just ask. Okay, because if you want to use the word given, right, this particular thing here, you must see in the question, which means questions must say. If the question never say they are equal, you cannot write given. Okay, when to write given? Later in questions you will see. Okay, but in this case cannot . It's there, but the question never give. So write it in the words. Okay. Okay, keep the questions coming. I like it that way. Okay. One thing to take note, common trend for questions involving similar triangles. Okay, straight away do AA first . Usually that's the trend. Okay. As a result, if you take a look at part B now, okay, suddenly what got quadrilateral now? If you have a part A finding the similarity, okay, if you take a look, this one is always making use of the similar triangles. Which is in this case, you realize how does it work? Let's check. QRAB is this one. What triangles have we shown is similar? Triangle ABC and triangle QRC. Where is the quadrilateral I'm finding? So if I want to find the QRBA with my similar triangles, what do I need to do? I take the yellow one. I use the red one to subtract from it, right? How do we do that? They tell you QRC is 18. They are similar. So the ratio is, this is 3, this is 7, right? If you have area of similar, what do we do to the ratio? Brandon, the keyword, if I find the ratio, what do I do? Square lah, okay? So that's why square. Square already, you have the ratios. In this case, I find specifically ratio or the area of the bigger triangle first. Okay, take note, my whole goal here is to find the bigger triangle first. After that, this is, if you take a look, big triangle and small triangle, subtract. Common trend now that you see from here. Can? This one have to, yes. Can go ahead, no problem. Okay, go ahead. Toilet is just there. You can, okay, since one person go toilet, okay, on the side, we take a quick 5-minute toilet break, then resume. Okay, understand it's very long, my apologies. We take a quick 5-minute toilet break. We resume at 3:15 before we go through the first one. Okay? Understand 3 hours a bit long, so that's why we take a break. Not tested? Yeah, that's why you have to refer lah. But again, you take your pick lah. If you feel it's not good for you, then yeah. Okay? It's not tested? Oh, but have you learned it in school? No. Okay. Okay, so that's why I suggest for IP you take a look at the syllabus first before you go through it. But you take your pick lah. If you feel it's not helpful, then yeah. Yeah. Sorry? Your parents just okay, good. Okay. Can. You see how much you can pick up. Okay? Okay, we take 5 guys, we use them at 3:15, yeah? Sorry? Can. Understand. The next class, actually, we are going through a bit of the triangle you have touched on is only right angle triangles, right? All sorts of triangles. Okay. So actually, the next class I'm covering, which is from 6:30. Here we go, a quick toilet break outside, resume in about 2 minutes. Okay, can okay, all right. Your online side, okay, just drop in again. I know it's not the easiest to do on the screen, so can you help me drop me a thumbs up if you are there, just to check in with you guys. Awesome, thank you. Awesome. All right. Okay, just hang in there, yeah. All right, okay, nice. All right, let's carry on. So over here, now, proving these two triangles are congruent. How do we prove? All right, first thing to take note, we will label the vertices down. So that means A, B, E. I have A, C, and D. Label like this, and then we will actually know which angles to use and how to prove. So one part here is, just now you're mentioning, Trevor, when to use given, right? Now over here, if you take a close look, congruent, we don't know what test to use. So we refer to the diagram first. In this case, first thing quite clear. Which angle will help me to prove for congruent? If you take a look at the order of the vertex. Which angle or side here? Okay. So just try, it's okay? DA. Okay, so DAE. Okay, take note, DAE, is it part of any triangle? So have to check. Okay, one part to be clear, it's okay, don't worry, we all learn from there. We need to know the triangles we are proving, so we draw out sometimes if the labeling is not clear. Okay, so if you take a close look here, which are two angles that we can prove straight away that they are equal? BAD, CAE. Yeah, these two are equal, but are they part of the specific triangle? So there's another one. It's given ADC, and which one the other one? This is when it's also justified because ADC, AEB, the order is there as well. This is when you use that reasoning because it is given in the question. Therefore, we can say given. Okay, and then also just check what is another part we can use to show that whether the angles are the same or angles or the sides are the same. Okay, another thing we can take note is, okay, if we have all these things here, how can we show? First one we have used already is the angle AEB and angle ACD, ADC. Second one, check whether it's relevant to the proof. AB equals to AC. We can use as well. You see that? Because it is written in this particular triangle, we can prove. So let's go to it. I have AB equals to AC. Again, this is the given part. Now, what happens? There's one more, right? I have BAD and CAE. They have yet to prove. But let's check. What is it that I can use here to show the congruence? We have BAE. Correct? Okay, let's try first. We have proved this one. Maybe let's try. Okay, we want to show maybe ABE, ACD. Okay, that's one way. But do you realize, is there any information that help us? If we take a close look, not really so, right? They look very vast apart. Not much info. So maybe let's try the last one. In this case, over here, I have BAE and CAD. I need to show that they are equal somehow. How do I show? Let's say I start from BAE. They are not so direct given in the question that they are equal. But let's take a close look. BAE, based on the info I have, you realize from the question it says BAD, right? BAD is given, right? Can we actually say BAE, based on this triangle over here, is made up of two separate angles? What are these two angles?
EAE.
DAE, CAE, not CAE, DAE is one, take note. I'm going to draw again. BAE is made up of, DAE is one, what's another angle? Do you all see that? So in this case over here, I have BAE equals to BAD plus DAE. Now, you may wonder, okay, sure, very nice. I write this down. How's it going to help me solve? I know BAE is equals to CAE, right? Let's write that down. Okay, and because this one, since it is given, we have to write given as well. CAE plus DAE, what is the angle that we get? Refer to the diagram. Okay, let me write it out for you all. CAE plus DAE, what's the overall angle? CAD, right? If I show these two angles are equal, does it correspond to the vertex that I am showing as well? BAE, CAD. So in this case, take note, I have two angles, one side. So this one, I give you the liberty. You can write AAS or ASA, but you must write the test now. In this case, I'll write AAS. Okay, what order to write? Okay, you check the angles you have proven. So let's just take reference on one triangle. So angle, I'm proving angle BAE and side. So because two angles come first, followed by one side, therefore AAS. But if you write ASA, they will not fault you because they are interchangeable. Okay, even though the order is different. Okay, so AAS, you can say angle ABE and angle ACD are congruent. Okay, so in terms of proving for similarity, this I would say is a little bit the hard part over here. For congruence, because there's a lot of things to look for. So what you can do, okay, take note, usually you start what is given. And you work out from that, it will be easier. Okay, cool? Alright, awesome. Next one. Part 2. You realize why got circles, right? This is where it gets interesting as well. But the good thing is, remember I said, all this info, we need to show that these two triangles are similar. Next question. Similar straight away. What is one test we straight away go on to? Remember what I said? Straight away think of angle, right? Let's look at our triangle. Again, first part, not sure, we label accordingly. B, P, Q, B, D, C. What are the triangles we have? B, P, Q, and we have B, D, C. Okay, so to show similar, straight away, try to see of AA. In this case, what is one angle? We can show that they are equal. QBP and CBD, yes. Okay, straight away find my common angle. In this case, QBP equals to CBD because common angle. Very weird, but we can write it down like this. Okay, the other one, I would say since they are parallel lines, you have the benefit of doubt. Okay, why? Parallel lines, we can either work with these angles or these angles because of the, in this case, F shape here. So parallel lines, remember ZFC, remember these few things. In this case, I work with BPQ equals to BDC. Okay, reason here is alternate angles. Okay, I have PQ parallel to DC. Alright, as a result from here, take note of the test you use, you must write it down. So by AA similarity test, I know BPQ and BDC are similar. Must take the test. After you use, you must write the test. Important. Okay, now the next one seems a little bit hard, but let's try to see how we can get to it. Okay, why do I say hard? Okay, one thing is we know the ratio. So you write it down first. Okay, a good habit is to actually write down the ratio. 2:3. Okay, and then we also know triangle BPQ is 25. So this is 25. So now if you take a look at the question, calculate the angle, the area of triangle PCD. Now where is PCD? PCD seems to be here, right? In this case, you may realize, oh, teacher Jason say I can take the big triangle minus the small triangle. But I realize if I do this, I'm only finding this one. The world will be nice if I can actually find out what is this particular angle here also, right? Area here. So what we do, okay? This one, another common trick, okay? I will work with that first step first. Then we will see how it goes, okay? So what we can do from here is from that ratio we find. Suppose you work it directly, you are not sure. We can do this. We are given area BPQ over, check from the diagram as well, area of BDC. This is 2 over 3 whole thing square. Take note, we have just shown from the question, or the question just gave us, that this particular value here is 25. Go here, what we can do, suppose you are just working it straight. Area of BDC. This is 9 over 4 times 25. Okay, suppose you work this through. Okay, then we'll be like, okay, all right, suppose you follow teacher Jason, you work it directly, and then you realize, oh, let's work out and find out what is area PQCD first. Suppose. Okay, work out straight and say, teacher Jason say, I can take the big triangle minus the small triangle. Let's say you work out this way. Okay, you are going to get 31.25. Okay, give me a moment. My pen just died down. Okay, what's that? Okay, 25. This is, okay, 31.25. Okay, then you realize, this is not the shape I want, because what I found is the quadrilateral. Then how? So one thing is this, you realize, if I can find this, I can just subtract, right? How to find? Now this is where I need you all to take into another way of finding your area. Okay, I am not too sure whether our teachers can emphasize this. Okay, suppose I rewrite in another ratio. I focus on, in this case, BQ and BC instead. Okay, BQ is 2, right? BC, can we say is also 3? Okay, this is 1. Okay, let me use the same color so that you don't get confused. Okay, now we know angle triangle PBQ is 25. Our hard obstacle is to know what is this, right? But one thing, do you realize that these two triangles are side by side? They are, right? They may wonder, okay, what is so awesome or maybe side by side? Why am I making the thing? Yes? Sorry? Okay, why is it half of 25? Why can I say that? Okay, a bit hard to say, right? Come, you want to try? You want to say something? 1/4. Okay, 1/4 cannot use because they are not similar. These two are not similar. But maybe more specific way I'm going to show you right now to this formula can always be used. It's half, okay? The side is half, yes. But, okay, once I show you this formula, I believe you will know why is it half. What's the area of a triangle? And the base is perpendicular to the height, right? So, if you look at the base, 2, 1, doesn't matter. But do you realize for both PQC and PBQ, share the same perpendicular height? So, if you realize if I want to find the area of PQC or PBQ, take note, it looks like the height is outside, but it's okay because I'm just looking for the perpendicular height with respect to the base. If I want to find the ratio, in this case, of BPQ, okay, to, let's say if you are working it out lah, PQC. What you are essentially doing for this specific ratio is doing triangles that are not similar but having a common height. Okay, W dash means common height. Okay, W dash means width. Okay, let's say if you cannot remember the base, you can always use the formula first. They share a common height, right? So let the common height be H. BPQ, my base is BQ. Height is, I don't know, H. PQC, my base is QC. Height is, I don't know, H. Cancel. BQ to QC, we work out just now. 2:1. This was 25. So, not only you are just looking out for similar figures, I also want you to take note for triangles that somehow are able to share a common height. Please use this to help you calculate as well. I don't know whether your teachers got explicitly tell you this, but with triangles that have a common height, okay, make use of their base. Not memorizing, I just ask you all what's the formula only. Calculating this accordingly, you realize, okay, this is just taking note that area of PQC is half times 25. This is 12.5. Now, we can have answered the question. What is the area of my triangle? This is 3125 minus 12.5. This is equals to 18.75. And finally, we are done. So why am I going through this question a little bit more slower than the others? Because for this one, it's not a usual similar figures. This is the part where sometimes you need to link your workings to. Triangles with a common height to link your areas. Not everything is square. Triangles with common height, must take note. Okay, can I move on? Part C. Nothing got to do with similarity, but let's go through. If they ask you what type of triangle is PAB, high chance, no sides label, few things like. Either asking you to prove that it's an isosceles triangle, or in this case, proving that it's an equilateral triangle. Usually these two things. Because there's no sides given. So isosceles or equilateral. Now, how to prove? One thing to do is, if nothing is given, what is the first thing you all learn in Set 1 of your life when you all come in? You all get used to models already. Then you realize when you all come in is, wow, I have to change my way of thinking. What is that thing you all have touched on so far? Now you all don't draw models already, right? Straight away you see all these things. You see 26 of them. Sorry? Algebra. What do I mean? We are working with PAB. Let this be X, no? Why? Because if I can show another angle is also X, I'm done. Isosceles, equilateral. I'm not too sure, but we work it out. From here, PAX. This is X. What other angles can I find? Okay, this is a circle we call circle. Is there a butterfly I can see? Okay, I can say that. This is X also, right? But because parallel, can I also say this is X because, okay, so this one I will skim through the process, but you'll get the idea. Know your properties well, starting from Set 1 and down. How do we craft the working out? Algebra is your best friend. First, let PAB be X degree. After that, we touch on, in this case, ADC, not ADC, sorry, PDC. PDC is equals to PAB. Okay, reasoning must state properly. We use angles in same segment. This is X. After that, we use it. Angle ABP is equals to angle PDC. alternate angles. And when we talk about alternate angles, we need to take note of the parallel sides. And since I know two angles are the same, not PDC, PBA. PBA. I know these two angles are the same. ABPA. Wait, sorry. Don't need to cancel. It's PDC, correct. I know these two angles are the same. Finish it up with your statement. Since PAB is equals to APB, your reasoning must state as well. What is the reason? By base angles of isosceles triangle. Okay, your triangle is isosceles. Equilateral, in this case, you also have to show that this is x lah. But we do know in this case, this is 180 minus 2x. Therefore, not equilateral, totally different things. Can see? So in this case, if you want to work out y, is it 60? Can we show that whether it's 60? There's not enough info to justify. So if there's more info, maybe you can show it's 60. But in this case, if you realize, okay, maybe you want to try to work out x plus this equals to 180. If you try to work out, you're going to get 0 equals to 0. That's a bit ambiguous. So in this case, just to play safe, with the info that you have, isosceles triangle is enough usually for this case. Equilateral, what happens? They'll have to tell you more info to work out for the accordingly. Can? Any questions? Alright, let's go on. Okay, now next one also congruent. Okay, now for this one, okay, this particular question, you have to take note of the particular properties of your different quadrilaterals. What do I mean? Rhombus. What can I say about rhombus straight? All equal sides, right? So in this case, I can actually say that AB equals to BC equals to CD equals to AD. Not sure? Okay, we can carry on. O is on AD produced. So I'm actually labeling my diagram such that AO equals to 2AD. Okay? AO is 2AD. So, which means it is 2 of this. So can we say these two are equal? We must write down in our working. But we must actually show that in our workings, these two are equal. So I'm labeling everything like this. Show that these two triangles are congruent. How do we show? ODE, BCE. Label as accordingly first. Okay, so take note what are the two triangles I'm showing. Not sure? Sketch it out. Okay, what are a few things I can straight away show? Rhombus also, besides equal sides, there's another thing I can show. Parallel, right? Okay, so in this case, over here, once you label the diagram, you realize one thing I can show straight away is these two sides are equal, right? But of course, we cannot straight away say OD equals to BC. How we did that is we got it from the info over here. So we have to write out what it means from the info given over here, which means it's this line. So I have just now, AO is 2 of AD. Write it out. My ultimate goal, what is it? I want to show OD equals to BC. That's my ultimate goal. So in this case, I know also AD, or in this case, AO, is OD or AD plus OD. This is from the diagram itself. This is from the diagram itself. And as a result, these two cancels out. I have OD equals to AD. Ultimate goal, I want to show OD equals to BC, right? Look at our diagram. AD already equals to BC, but it's because of the rhombus. So my final statement, I'm so close. But the only thing I need to take note is, I need to write out my reasoning here. Since ABCD is a rhombus, I know AD is equals to BC, where I have shown just now. Sorry for that. Can you help me write OD at the front first? Because OD equals to AD equals to BC. Therefore, 1 is done. OD equals to BC. So this is a side that's hard to prove. But the whole thought process is down there, where we need to make use of the geometrical property of a rhombus. Once you're down here, one side is done. Check whether we can find another side. Okay, a little bit hard. So next one, we can take a close look. One of the angles that's very easy. Okay, sec 1 when you're a favorite, vertically opposite. The other one, very good. So we write this down now. So once we have that, we write it according to the vertex we have. So I have CEB equals to DEO. Vertically opposite angles. After that, the other one, BCE equals to ODE. Alternate angles, take note, I must write with my parallel sides. And in this case, take note, two angles, one side. So ASA, AAS doesn't matter. AAA, no, AAA cannot congruence. AAA is similarity because you can have all same angle, but if my triangle is super big, example, this is my triangle, all same, right? I can have a triangle, they are not congruent. So AA, no AA congruent. Okay, so you don't have AA congruent. Okay, so this is one example. There's no AA congruent. Okay, so I have CDE is congruent to ODE. Okay, can? All good? Can Okay, now congruent is the harder part. If I look at similarity, you all know what's next If I take a look, ECF. This is ECF. This is BAF. Again, I look at these two triangles. Remember, when I talk about similarity, what is one test I can straight look out for? What's one test I'll straight use? If you talk about similar triangles to prove them. Two angles, right? AA, right? So straight away, you see, want to prove they are similar, try to link to AA straight. If I take a close look, first one, our favorite. If I look at my triangles, vertically opposite. Then after that, just now you mentioned alternate angles Okay? Note of the triangles I'm proving, then we can go from there. Okay, first one, in this case, write according to our vertex. Okay, if you are not sure, repeat again. E, C, F, B, A, F. Refer from the triangles I have. I have E, F, C equals to A, F, B. Because they are vertically opposite. The other one, ECF is equals to BAF. This is because alternate angles. I have AD parallel to DC, cos of rhombus. So that's why I refer to the properties that I have. After that, finalize with the similarity test that I'm using. By AA similarity test. ECF is similar to BAF. Must write down the statement at the end. Okay, got it? Okay, now last one. You may realize from here, I don't even have any values at all. How do I even know what are the possible values? So if I take a close look, this is where you have to take note. What are the different things that you can find out from my triangles here? One thing we can take note over here, if you want to get values. Similarity, if you can making use of AA, one thing is you need to make use of the ratio. There are no numbers here in the first place. Nothing can help you. Refer to the parts. Congruent, think about it. All sides are equal, right? So if I take a close look specifically for this question, ECF, I know they are similar, so I can square the values, correct? ECF, BAF, very nice, I can square the values. But if you take a close look here, do I even know which sides I need to use? Nothing is given, right? Okay, so maybe B, C doesn't help. Let's look at A. Let's try to see how it can help me. Okay, OD, BC, they are equal. Doesn't really help. Maybe I do OE, BE. Doesn't really help at all. But if I take a close look next, if I see CE, DE, they are equal, right? Is there any other things I can say about that from here? I give you a hint. If they are equal, what's their ratio? 1:1, right? Because of 1:1. For a rhombus, this is equals to this. So 1 plus 1, 2. What is this length here? So what is the ratio now? 1:2 square, 1:4. So realize over here, I am not saying that, okay, all these things are conjugate of mid-air, but refer to the previous parts. Similarity, I only have angles. Does it work for me? No. Always remember there is a reason why the question gives you in parts. If you have solved it, you can use it as a extra info to help you. Not just specifically for this question, but in general, if the question is given in parts, treat it as an information that is to help you for later. In this case, you don't have to show this because it's 1 mark, so it's really area of ECF is to area of BAF. 1 square, 2 square, 1:4. Thought process is what we have touched on just now. Any questions? Can I hang in there with me? I know it's a long one, quite tough, so hang in there with me. Okay, all good? Just hang there with me, Can? Online side, if you're okay, come just give me a signal, drop me a thumbs up as well. Okay, if you have any questions, please type in the chat, yeah? Alright, thank you. Now, the first few parts are actually the harder parts for area of similar figures and volume. This one will be the easier one. Why? You don't need to find the corresponding sides because it's an object. You are not supposed to find the corresponding side of this. It is not possible. Curve side, how to find? They will tell you the figures used. They will tell you the sides you need to use. What do I mean? Okay. Part A is just to tell you there's an additional part that you may need to use. Best or value for money. Over here, I'm just making use of the concept of weight. Nothing related to congruence and similarity, but something we can rely on or something we can spot on when we have such questions. It's more of the next part. Once you see geometrically similar, if they give you a height, you can rest assured that's the value you can use. Okay, so example, in this case, the height is given and in liters. Take note, if I say liters, this is your volume. Volume, remember, if I have the ratio of the volumes of the number and I form my ratio corresponding height of 2.5 liter corresponds here, height of 800 milliliter corresponds here. If I have the ratio of the volume, take note the opposite is to cube root. Because originally it's squared, I have the volume, I cube root. From there, how I get the height of the water, it's given as this is 12.5. Okay. Okay. All right. Give me a moment, sure. I will question C. Okay. All right. So just take some part to understand this. Part C. Yeah. Part C is just this one. Okay. Give yourself some time to refer to 4, 5, and 6. I will assure it's quite quick. Teacher, once you are okay, just let me know. Type in the chat whether you are fine or drop me a thumbs up. Yeah. Yeah. You can just drop me a thumbs up. Okay. Awesome. Okay. Now next one. Okay. Now ask yourself in this question. It is not necessarily the case whereby they give you the ratio of the sides. What ratio did they give you here? Surface area, right? So in this case, what happens? Take note, when we work with the ratio, we try to work with the ratio of the lengths. So given this ratio, 25/36, okay, maybe I wake up your brains a little, understand it's a bit tough. What do we do with this ratio? 25/36, but if I want to find the ratio of the lengths, with this ratio, 5/6, how do I get that? Square root. Okay, very good. I heard the finisher lah, square root. So the length over here is just 5:6. Where we take note, the smaller one is L1. The bigger one is L2. Okay, now, henceforth, I am working with the volume, yeah? From here, Trevor, can you tell me what I do to the ratio? If I want to find the ratio of the volume? Cube, very good. Okay, this one just take your calculator and cube lah. 5/6 whole thing cube. Okay, and in this case, the smaller one is 8,000. So 8,000 over V2. Quick work here. 125 over 216. From here, we do V2. V2 is the bigger one, yeah? The 2 is always the bigger one for the case. I mean for my annotation. But if you want to write 1 as the bigger one, I give it up to you. Okay, calculator press 13824. Okay, so always tell yourself when you're given the area, always work towards the length ratio. Okay, so this is really quick work down here. Okay, got it? And awesome. All good. Okay, now this is straight away telling you to find the volume. Let's level up a little. Let's try to find the volume of the base area. But you look at this, a bit confusing, so you need to keep track. Okay, Brandon, can you tell me what ratio can I find from the given info? Find directly. What is the ratio I can find directly? Okay, that ratio you find 192 to 24, that ratio is the volume, surface area, or height? Volume, right? So we know we can work with the volume. And in this case, from here, they give us the height. So Trevor, can you tell me what can we find from the question first? If we have the volume ratio, what? They give us the height. So if they give us the height here, very good. But you take note, I have to find the ratio of the base area. But we keep this in mind first. It's okay. We work with what we have. Okay, so over here, take note, we call volume. Okay, again, referencing for my part, this is the small one. This is the big one. Okay, recall I am taking, in this case, the corresponding heights and cube. I almost say square. It's going to be 24 over 192. This is equals to 4.5 over H2 cube. Okay, if you take your calculator and press 4.5 over H2, I cube root both sides, you're going to get half. Solving it accordingly, you get a 9. Now, take note. I know my height now here is 9 cm. I want to find the ratio of the base area. I know the first one is 4.5, second one is 9. What do I do with these two numbers first? Square. Very good. That's it. So if you want to form the ratio, the base area of the small pyramid to my base area of my large pyramid. Okay, 4.5 we square, 9 we square. But take note, you are going to get two weird values. Don't work with them, simplify. Because they ask for ratio, that's why I have the dot dot. Okay, and now, last one is a common variant of a question whereby they like to mix cones together with similar figures. What do I mean? Find the ratio of A to the whole cone. The only thing they give you is the ratio of the slant heights. But take note, the slant height are not the cones. LA, if you take a look, this is 2, is to 3, is to 5. These are the slant heights of these things specifically. So if you want to find the volume, we need to make sure that the shapes are similar first. Take a close look. My A is this one. My whole cone is this one. Are they similar in the first place? No, right? One look, no, very good. So how do we solve this type of questions whereby I have a cone and then they cut it out? We have to make use of the actual similar cones. Remember when you did the quadrilateral, you take the bigger triangle minus smaller triangle? Similar concept here. How do I get volume A using that concept? If I have the whole big cone, I want to get volume A. What do I do? This is the big cone. I want to get volume A. What must I subtract from? Second one and third one, right? Because this is similar to this, right? I can do the subtraction. But before you do the subtraction, take note. We know this whole thing is 8 is to 10. Before we do the subtraction, what must we do to my 8 and 10? Because I'm finding volume. Sorry? Before you subtract, what must I do? Because it's volume, we must cube. And then you cube. This one only cube because I'm finding volume straight. Okay, so what happens? As a result, if I want to actually find the volume using my similar figures, which you don't have to prove, okay, volume of A to the volume of the whole cone. My whole cone is 10 cube. But my volume of A, take note, I need to cube the numbers. So I actually have 10 cube minus 8 cube. This is this way. How do I get 10 cube minus 8 cube? We call, if let's say I call this shape. Okay, so this is my volume. If I follow my color coding over this volume is 8 over 10 whole thing cube. Okay, so if I just want to find the blue color one, this one is the blue color one that I'm just finding so far. So my color coding here corresponds. Okay, can? Now, next one, same stuff. If you take a look, given volume A, calculate volume of B, it looks like I need to calculate the two volumes straight. But take note, A is not a cone, neither is B. B is not. So take note, if I want to find the volume of B, I need to make use of the subtraction of two cones again. In this case, take note. Oh, yes, in this case, B and C, very good. So therefore, my whole cone is 8 cube minus 5 cube here to get me B. Yeah, okay, I see nodding of heads, that's good. So same stuff here by similar figures. Volume of A is to volume of B. Take note, these are from the cones. I still need to do my subtraction. 10 cube minus 8 cube. This is 8 cube minus 5 cube. I'm taking the B cone plus C, B plus C minus C. I will get 488 minus 387. This is the ratio that you work with already. Don't cube again, because it's your volume ratio already. After that, you can work with the ratio that you have. Form in terms of a fraction. It will help you more. Volume of A over volume of B. 488 over 387. I know in this case, my number here is 122. So, therefore, my volume of B is 387 over 488 times 122. This is my volume. Same stuff, you all got it down quick. That's awesome, all right? But just take note, we can only work with in this case, we can work only with when they are actual cones. Don't just take the lengths and square and cubes in this case. They do not work. Okay? And all good? All right, let me move on. Okay, online side, just check if you're all good. Drop one more last thumbs up before I go through the last part of mensuration. Awesome. Okay, just a quick one. Now, these ones are the formulas that are supposed to be familiar. So just take a glance and take note that none of the formulas are actually foreign. They should be, you see it, you'll be, I have seen it somewhere. You haven't seen it somewhere, please let me know. Okay, but I think all these definitely see before. 2D mensuration, these are the formulas you have. This is 3D. You have two cases. What is uniform cross-section area? Example, let me use a prism. If I take a knife, I cut through here, I still can form a triangle. This is what you call uniform. You have that triangle uniform throughout. Okay? But sometimes the world is not so nice. You have these ones over here. And a good news is, some of them are actually provided. Okay, I'm not too sure, but I also heard from some schools they are quite stingy, so just check at your site. But in general, they are provided. So you can take note. One note over here. Formula of the volume of the cone. Please familiarize it yourself, even though it's given. If you take a close look, we went through that just now. Something got to do with cones and similar solids, right? So take a look from there. All right, it's very, very, very common if they want to actually mix these two together. Okay, what are some different kind of questions? First one, okay, they can actually mix up stuff. They give you all these things, okay, so hemisphere, radius 6, frustrum. Okay, what is a frustrum? Okay, in case if you're not sure and you are not supposed to know anyway, okay, they will tell you the details. What they do, they cut a circular cone. So basically, as you can take a look, this cone here, they cut out this cone. That's your frustrum. That's it. Okay, so height of the cone, how do you get that? Okay, in this case over here, firstly, usually similarity, you need to show the similarity. But this one, too much, no need. Where is the similarity? Okay, take note, these triangles here. Okay, so I have, in this case, we note that this is 10 and x, but you realize where I get my 6 over here? Okay, my radius is 6. Cut from here to from this side. Okay, I'm just inserting right at the top. If this is 6, because it's the radius, this part has to be 6 as well. Because I'm fitting it directly at the top. Radius is all throughout from the center. So I then know this is 6. Okay, if I know this is 6, okay, and the question gives me that the cone is 8 with x over here, I take the subtraction. This is 8 minus x. So I have 8 minus x over 8 and 6 over 10. Okay, for me, the ratio subtraction, this gives me the 3.2. Okay, this is your similar triangles. Once we have this down, find the volume. I would say the volume part is quite okay for you all. It's just utilizing the formulas. In a way, what I mean, this is your frustrum, not frustrum, this is your same hemisphere. We just find the volume of the hemisphere, which is, take a sphere, divide by 2. 2 over 3 pi r cubed. Your frustrum is the harder part. Why? We have a bigger cone. We need to find the volume of the bigger cone, subtract with the smaller cone. So that's why if you look at the working below, the radius respectively 10, 8. Okay, what I mentioned just now, we take big cone minus small cone. Hemisphere is half a sphere. We call a sphere formula is 4/3 pi r cubed. So half of it is 2/3. After that, I just add that up. Okay, now for the second part, you have to take note for surface area, right? For surface area, we have to take note what parts are exposed to the outside. That's why surface. In this case over here, okay, didn't get you all to speak to me before you all are crashing. Over here, Trevor, can you tell me for the surface area of this one, which is what we are finding, which parts are exposed? This one, okay. And this, and what else? There's one more. And the circle below, right? So take note, if you were to just whack your formula for surface area, for volume, for surface area of a sphere, which is 4 pi r square, it doesn't work. We have to work them separately. which if you look at the formula, first part, I'm only working out the, okay, in this case, find the surface area of each component. First part, I am only making note of the curved surface area. Curved surface area, how does this formula works? This is pi. Okay, these are your two R's. L over here, I can find by your Pythagoras. 8 square plus 10 square. So in this case, just letting you, if you're wondering, this is my 8, this is my 10. X is 3.2, 8 minus 3.2 is 4.86 to find this and this respectively. Working out your Pythagoras, we can go ahead and find the curved surface area of the hemisphere, which is just the curved part, don't at the bottom. Because when you find the whole surface area of a sphere, it's just, all right, 4 pi r squared. Divide by 2, what exactly is it, the curve? If you think about it, I have a whole ball, I cut it out, I'm only left with the curved part, right? Is there anything at the bottom? No, right? If I cut the ball, what is left is just the air on top. So when I cut out, I'm just left with the curve. So that's why 4 divided by 2, I exactly get just the curved surface area. There's nothing at the bottom when I cut out the hemisphere. After that, I add everything short. Okay, just a note here, I do BC, SC, cause the sentence is a bit long, so just bear with me. Okay, can? Now let's go on towards a common style of question. So this is a square-based pyramid, even though it doesn't look like a square. So just bear with it. You'll be like, oh, teacher, this doesn't look like a square. It's just the way of how it is looked like there. Okay, total surface area of the pyramid over here. All right, this one, a benefit of doubt. They tell you AN is 6, but it's not labeled. So just label them. In this case, sometimes it's good to just label. So I have AN is 6. Okay, calculate the total surface area. Now, Brandon, can you tell me over here, to calculate the total surface area, what must I find? Correct. So literally, triangle we know is just your half times base times height times my square. Calculate them separately. Okay, really your 4 triangles and my square. Okay, now next one, volume. In order to find my volume, Brandon, can you tell me what is the formula of the volume of a pyramid? Do you remember? Or if you're not sure, it's okay. I think you mentioned before, it's alright. Yeah. 1/3. Yeah, correct. Trevor, what is missing there? I have 1/3. I have the base area, the height, right? Okay, one shot. How do I find the height? 6. Very good teamwork over there. So 6 square minus 1.1 square. Basically, you all have told me the answers, the workings ready lah. How to write it out so that it's accurate? Tell me this statement. I am not too sure, again, if how particular your teachers are. So just say, in this case, I want to find AX, which is square root of, in this case, 6 square minus 1.1 square. Okay, 6 square minus 1.1 square, I have 5.8983. Therefore, the volume of the pyramid is 1/3 times 2.2 times 2.2 times 5.8983. 1/3 times base area, this is my square followed by the height. I have 9.515924 This is 952. Okay? So basically noting what you need and what you need to find. Okay. Can all good? Okay, just two more hang in there, just to expose you a little bit more. Next one over here. Can move on. Now this one, the first two, I'll just go through accordingly. Alright? Because I believe it is not too tedious. Okay, but it's a C and D I want you to take note. Volumes, I don't need you all to be too particular. First, find the volume of a hemisphere. Okay, we know your volume of a hemisphere is just 2/3 pi r square, cube, sorry. So we have 2/3 pi 5 cube. That's it. So in this case, we have 261,799. Round off to 3SF. I have 262 cm cube. Okay, remember your answers are to 3SF. Now, the other one a little bit different, but more or less, I believe you can get it. Okay, they give you the volume of the ornament. Find the height of the cone. From the volume of the ornament, what is one step we can take first before we find the height of the cone? What should we do? Brandon? Of the volume of the ornament, I want to find the height of the cone. What is one step we can do first?
You first deduct the hemisphere together.
Very good. Then after that?
Base and
Okay, I think utilize the formula lah. Okay, so awesome job down there, utilizing the formulas. Take note for this one, I will utilize this number. Don't use the exact one because this is an intermediate process. Always use your intermediate working for later parts of the questions to ensure accuracy. Don't have rounding error. Okay, so we have in this case 151,201 cm cube. From here, volume of the cone, we know our radius is 5. This is 151,201. Height, just take your division. Normal division, just do it. Denominator at 3 is times 3. We divide by 25 pi. Do it as in take your calculator, press it. You are going to get this height. Okay, that's the height of the cone. Okay, nothing too fanciful over here, really. Okay, volumes, that's why these two I kind of speed it up. But next one. This one I have to make it clear. Okay. Now, let's picture. If we want to form this metal ornament, which is this one, I am forming this by melting. Now let's recall this concept of melting here. Will the volume increase, decrease, or stay the same? Stay the same, right? All right, because if I melt, assuming I don't, I splatter the metal. Or let's say, I don't accidentally add some extra material to make the metal like very weak or something. Your volume is going to stay the same. So that means if I melt the solid cylinder, it will be equals to the amount of metal ornaments that I can make. So first up, we identify what is the volume of the cylinder, which is pi is diameter, so we need to divide by 2 height, pi r square h. 7539822. Previous question tell us the volume of the metal ornament is 413. We have the cylinder, so our number of metal ornaments will be this number divided by 413 And in this case, I have 18,256. It won't be a whole number. But take note, regardless of my decimal point, even though if it's 5 and above, for this scenario, do we round up or round down? Down, because the extra material, we are not able to use it anyway. Okay, this one, tricky. Looks simple, but take note, I am packing. So this is fitting, this is not melting. So for this particular question, we have to ensure my length, my height, and the width, all right, in this case over here, 100, 40, and 65. I need to make sure I'm optimizing the cylinder arrangement. What do I mean? Height 24, diameter 20. There are a few ways I can arrange it. The first way, which is the normal way, I can arrange it up top like this. Okay, this is 20, this is 24. But there is another way as well. This is only one way. Take note, this is not cube. You may wonder, why this one I need to rearrange? I recall this type of question no need to rearrange. Take note, common style of questions is you are fitting a cube in the box. Cube, no matter how you rearrange, is the same one. But for this one, it's a cylinder. So you need to take note, one arrangement is this way. The other arrangement is, let's say you have this one. I can do it this way, where this is 24. And this is 20. The last way to do it is this way. So this one is a little bit harder because we actually have to venture into all three different considerations and find out which one is the one that allows the best packing. Okay, the last one is, let me draw out. So the last one will be the circle this way. In this case, height 24, diameter 20. Okay, so I will do the hard work for you. You just need to work out the orientations, and what we will do, we will actually work out all particular dimensions of the length, width, and height specifically. In this case, after hard work, okay, this will be the one. You can work out the other two and check that actually the orientation doesn't work. What do I mean? Lengthwise, I have 24 of 100. I need to fit of length 24. Okay, I'm working with this one. This will give the optimal. Okay, this will be 4.16. I cannot fit the 1/6. I round down. Widthwise, I have 65 divided by 20. Okay, I know I have 3.25. This will be round down as well. Height-wise, this is 40. I can only fit 2 of the heights. So therefore, the maximum cylinders, I can fit 4 lengths, 3 width, 2 heights. Similar to the cube at this point. For this one, moral of the story, it's very similar to your cubes. But what we need to consider is the fact that because it's a cylinder, dimensions are different. We need to take note of the different orientations here. Okay? Got me so far? Awesome. One last one. Almost there. Which is where I'm going to go through that particular variant. Okay? Now, this one, don't get confused about the radius here and the dimensions. Why? Point O is the center of the sphere with radius 12. This 12 here refers to from the center to the part of the circle. It is not your radius here. Please be careful. Okay, just taking note over here for reading info. Now, they tell you given the circumference of the base, they want you to show the height of the cone, which is this one. Now from here, if I want to find the height of the cone, Trevor, can you tell me what do I need to find specifically? Let's break it down. Okay, let me label part for you. I know it's a bit hard for you to say what. Okay, let's say this is A, this is B. What do I need to find? B, right? In this case, OB, right? Why don't you find OA? Very good. Okay, we know it's radius. Sometimes I ask all these questions to confirm that you are aware of what you're finding. So I need to find OB, right? Okay, so this is what I need to find. Now, if I need to find OB, again, I'm using the reverse engineering technique. I need to find this, right? This is the radius of the base. Is there any info in the question where I can find the radius of the base? Very good. Circumference of the base. Circumference is 2 pi r, not pi r square. R is then 50 over 2 pi, which is 7.9577 cm. Do it in 5 significant figures so that your values will be accurate. After that, you are then finding, in this case, since I'm labeled already, OB. OB is by Pythagoras theorem. Okay, so I have 12 square minus 7.9577 square equals to 8.9819 cm. Once you have that, we know the radius is 12. We add them up. Height of cone. Literally, just add them. 12 plus 8.9819. This is equals to 20.9819. They want 3SF. Give it to them. 3SF. Okay? Working wise, I don't really care on the manipulation, but more on the thought process. That's the main scope I touched on just now. How we get to the answer. Okay? Not this part. This part I believe are okay. It's the how part. Find the curved surface area of the cone. Pi r L, right? So in this case, you realize now we have the R, which is 7.9577. We know this is 8.9819. The thing we are lacking, we have the R, we don't have this. All right? So that's why over here we are using Mr. Pythagoras to help us again. Okay, so pi r L standard processors that I'm reminding you all. So the slant height of the cone. This is Mr. Pythagoras in action. So I have 20.9819 square plus 7.9577 square. This is 22.440 cm. 5SF, 5 to 7. If you want to write more, can, but no need to write the whole calculator value. Too much. After that, curve surface area. Literally put what is needed. You have pi, you have r, you have L. to 3SF. This is enough. Now, once you look at the third one, does it look very familiar? Looks very familiar, right? It's the one, the cones where we have the height. Just that instead of giving you the slant height, they give the particular heights like that. Concept is the same. Okay, what do I mean? But take note, you have to read it carefully. The cone, okay, you have to read it very carefully. Don't get tricked. Okay, what do I mean? Let me scroll down. This cone over here, is it the cone in dotted? Read the question description. I want you all to read. Is it the dotted cone? Do you say yes or no? Yes or no? Brandon, read the question. Is it the dotted cone? Okay. One say yes, one say no. Answer is, read it. After the cone, I cut out from the sphere the remaining steel is melt down to form the cone. So you must read. That's why they purposely put a cone here to trick you that it's the same cone, but it's not. So you have to be very careful to read it through. Okay, I am finding the remaining steel. So something for you to take note. Okay, this is one thing. It's the remaining steel that is formed of the cone. After that, there are a lot of details. But one thing to take note, you see this, you know volume of similar solids is coming. Yes, that's right. Okay, after that, what happens? 3 layers of equal height. Okay, so what do we need to do? If you want to find the volume, we need to know what is our actual volume here first, right? Take note, your actual volume, you all tell me, is not this volume, it's the whole sphere subtract by this cone, which is what we are going to do. Okay? Volume of cone in the sphere. I have 1/3 times the radius, 1/3 pi times the radius in the question times the height. This is 1391.4 cm squared. Remaining steel is the one that forms the cone at the top. Okay, 4/3 pi, 12 cube minus the cone here. Okay, just give up to 5 to 7 significant figures. In this case, I write 5. Okay, now, remaining steel is this, right? We apply our formulas now. Take note, when we apply the formula for similar solid, it is respect to this cone and this cone. So reminder, when you're forming your ratios for this question, okay, sorry for exceeding. I think I'll be finishing in 5 to 7 minutes, so just bear with me. Ratio of volume. If I label according to this, suppose I do this. This is my A, this is my B, this is my C. Supposedly, to make it my working easier. Your ratio of volumes will be A plus B, A plus B plus C to give me H cube, 2 of H cube, A plus B, 2 heights, 3 H cubes. So I have 1, 8, and 27. Now, this is where I want you all to take a close look from the ratios here and the question, the question. Which units here is the one that forms from the remaining steel? I give you a hint. Read the question carefully. I think you all are tired, so I give you a hint. Specifically, this part. Okay, I hear something. You say top and bottom. So I must do a little bit of some things to the ratio. So of course, once you say top and bottom, you realize it's neither of these three. Top and bottom, so what must I do? Okay, it's 8 plus C, which the units there will be. Okay, A minus 1, very good. Okay, I hear good stuff. Carry on, carry on. Okay. Okay, 8 minus 1. Why 8 minus 1? 8 minus 1 to give me this. But after that, take note, I want the top and bottom. You only give me B. So in this case, it's not 19. I think you all checked already. So 20 lah. How you get 20? Take note, I help you out lah. A plus C. This is 20, but take note, this is these 3 minus the 2 plus back the top. So I have 27 minus 8 plus back the top. That's why 20. With this, I know this is the steal, but take note, why do I find all this? Question asks you to find center layer. Center layer is how many units? Very good. So 7, I know my 58.468. This one, the remaining steal is 20 units. So use your normal proportion ratios and form out. So volume of my acrylic is this. 7 over 20 times 5846.8. This is equals to this. So this one, okay, why I want to do this, even though it feels like the same as your previous 3 questions, is because of the concept of similar solids they can mix together and the tricks they can tell you. Example, first one, you all may think the cones are the same, but no, it's a separate one. Okay, I think acrylic I spelled wrong. Sorry, there's no C here. Okay, then after that, ratio of volumes, you have to take note what is the one that forms the steal. Some of us will assume 27. Okay, so the tricks in the question, the different thought processes on how you approach. I hope you guys get a little something for today lah. Okay, any questions down the floor? All good? Can? Awesome. Okay, online side, if you have any questions, feel free to type in the chat. Let me just share a little bit more on what is happening for you all lah. So in this case, I hope you all found this useful. And in this case, and also if you found this useful, I'm gonna leave this screen here for a while. For the online side, a bit hard for me. But if you feel that this is good, okay, if you want a full scat pad, okay, feel free to scan the required QR code, and then you can get a full scat pad from me lah. If you feel shy to scan now, you can scan later. Anybody want to scan? Up to you all. Anybody want a free full scat pad? No force, Okay. If not, what happens? This one I want to emphasize. If you actually indicate your early interest, you get all these benefits lah. Take note, you all don't have to pay for anything for this one. It's just if you sign up, you are indicated a position. There is no downfall of any deposit you need to require as long as you sign up. First now to secure your position. After that, when you actually try, okay, after that, when you actually register, it will apply for you all. Okay, and also if you're interested in my classes, okay, for next year, in this case, you are going to IP3. Okay, give me the scan over here. For me, my slot is on a Monday night. So if that slot is good for you over here, feel free to scan. Otherwise, that's it for today. Thank you very much. And yes, if there's any questions, feel free to ask me. Let me stop the recording.